Hello, today we're going to be working on activity 2.2.2, chain reaction for principles of engineering and project lead the way. To do this, first we need to open up our code v5 vex environment, and we're going to do file, new text project, and select Python as our language. The first segment has you start by just doing a simple code for a motor. So first we have to plug our motor into port 5 on our brain, and then we have to set that up in our coding environment. So we're going to device, add a device, we select motor, and port 5. You can change the name if you want. I'm just going to keep it as motor 5 and click done. Once that's in there, I'm going to minimize, and then I'm going to start my code. You can either type the code directly in, or you could drag and drop it over. It's a short code, so I'm just going to type it in, motor, and whenever it starts to make this, you can hit tab and to accept that statement. Then I hit dot, spin, and again you can hit tab to accept, and then I want it going forward, so I'm going to hit tab again. Close my parentheses and hit enter to move to our next line. Next, it says to make it say wait. So I hit wait, and then again I'm hitting tab each time once it pops up as an option, comma, I type my 2, then comma, and again it gives me that option, so I'm just going to hit tab and then close my parentheses. Then I hit enter, go to my last line, and then again start motor, I hit my tab, I want to tell it what to do, dot, stop. Make sure you put parentheses on the end, either by hitting tab or typing in those parentheses yourself. Once you do that, you have to make sure to connect your brain if you haven't yet. So you go to brain, connect, hit continue. Make sure you select the right one. If you're not, it usually gives you an error message. And then we have to download this to our brain. It gives you the option to save it, and we're going to hit save, and we want to say where to save it. I'm just going to put it in my downloads, and I'm going to make it 2.2.2. Since I already had one, I'm overriding that one and uploading that to my brain. And we'll pause it and check out this code on our brain. So we have our motor plugged into port 5, the motor sitting back here, and we're going to run this code real quick. So I'm just going to hit run and let it run. You can see the motor runs, and then it stops. And then we're going to stop our code, and now stop. Next, we need to add a potentiometer. A potentiometer says potentiometer. It can be either red or there's some gray ones as well. The gray ones have a little larger range that it can spin through. But the way essentially this works is we put something, an axle through there in some way. We put an axle through there, and I got tape on it so you can kind of see where we're at. And it can spin through a range until a limit. It's kind of like a thermostat, an old thermostat or an old radio dial. We can spin it, and it's going to adjust to your values based on how it spins. Once we have that potentiometer, we have to plug it in. It's a 3-wire port, and it's just going to go in the end of your brain. It says to plug it into port A, so we're going to set this one up. I'm going to rotate this around and plug it into port A and make sure it gets seated all the way in there. So that's how we set it up. Now that we have our potentiometer plugged into our brain, we want to set it up in our coding environment as well. We click Devices, add a device, scroll down to 3-wire, click 3-wire, and then we find the potentiometer on here. We select that, tell it what port we plugged it into, in this case port A, and then we're going to select Done. That adds it to our coding environment. Next, we're going to get rid of this code we just did. We don't need that for our next step, so we're going to get rid of that. And now we're going to make it so the values from our potentiometer show up on the screen. That's really good to have, especially if you're troubleshooting or you're trying to see the limits of a different device. To do that, we're going to start by going to Looks, and then we're going to start by clearing our brain screen. So we're going to, first, before I do that, I'm going to do a while true statement so we can have this go on forever and not just get that initial value. So I'm going to do while, and then I'm going to make it just true, and then end it with a colon. Hit enter to go down, and then we want to be indented under this code as we add in each of our next statement. So while true, first we want to clear the screen. So under Looks, we're going to drag and drop brain screen clear screen, and then we hit enter. Then we want to tell our cursor to start at the beginning at the top. So we're going to set brain cursor 1 1, and I'm going to hit enter after that. And then next we want this very top line brain screen vex code. However, we're printing the vex code. However, we have to tell it what we want it to print. So instead of vex code, I'm going to highlight that, delete, and we're going to put in code from our brain screen. So we're going to go to sensing because we want to use our sensor, and now we have to find the potentiometer on here. So it's got a bunch of options already. We want to find potentiometer. It's all the way down here at the bottom, and we want to drag that inside those parentheses. Potentiometer a angle percent, and that's going to be our next line. Once we have that, then finally we want to add a wait time so it has time for it to sense and show these values and it's not always jumping around. Usually I just typed it in, but I'm going to go over here to control and wait 1 second and drag that underneath, and then we're going to change that 1 to a value less than 0.1, so I'm going to do 0.05. Once you have that all typed in, then we need to download this to our brain. If you're not already connected, you have to reconnect. If so, you can just download. Now we'll check it out. So I have my potentiometer. I got the tape on here so you can kind of see where we're at. I'm going to hit run, and it gives us these values. It might be kind of hard to see on our screen. It says 0 when I'm down it, and I'm all the way on the left-hand side. I'm going to spin that all the way to the right-hand side, and you're going to see it's now at 100. If I go somewhere in between, let's go somewhere in the middle, you can see now we're at 28. Or if I go up a little higher, now I'm at 47. So that kind of shows you the range for your potentiometer. There's another way you can look at your potentiometer value, and we'll hit back, and then we're going to hit devices on our screen. We're going to hit this triangle with the asterisk inside it for the 3 wires, and this top one, since it's plugged into port A, shows us our value for our potentiometer. So it's at 2100 right now. I'm going to spin it all the way back down to where it's at 0%, and now you can see it's at 10. And then I'm going to spin it all the way back up, and you can see all the way back up, my value for 100% is 4095. So that kind of shows you that range of values for your potentiometer. Next, we want to use the potentiometer to control our motor. So I'm going to go to this line. I'm going to move this wait statement actually down below so it's at the end of our statement, and then I'm going to go below this brain screen statement. And I'm going to start with an if statement. So I'm going to type in if, and then hit tab, and then my condition, I want to tell it what to do. So the condition I want to use is going to be my potentiometer. So if my potentiometer, and I'm going to do my angle. So if, and then controlling or sensing, we go down to our potentiometer, and we want that angle, that same angle statement. So I'm going to drag and drop that in. So if my potentiometer a angle percent, and we want to say is greater than 50%. So we're going to do greater than 50. Then we have to tell it what to do in this pass statement. So what we want it to do, we're going to say we want motor 5 to spin. And then what direction we want it to spin forward. Then we might not want it to spin when it's less than 50. So there's 2 ways you could do it. You could add another if statement, or you do an else. I'm going to do an else in this case. So I'm at the same indentation as the if. I don't want to be below where it said motor 5. I want to be right below where it said if. Else, and then I need a semicolon at the end of that statement as well. I hit enter. It's going to be indented some just like motor 5 was, and I'm going to do motor 5 again, and I'm going to tell it to stop. And again, you need open and close parentheses here. So now I can move my wait statement up, or we can keep it down, and it's not going to affect the overall. And then we want to download that to our brain. Once we download it, then we can go over and we have that code downloaded to our brain. I'm going to hit run. Right now I'm at 0, so my motor's not spinning. As I move it up above 50, you can see our motor spins. If I move it back, it stops. Move it back up, it stops. It continues to go. And I can use that potentiometer to control whether my motor runs or not. Next, we're going to add in a bump switch. A bump switch is just a little press button, and then we're just going to plug that into port B. So it's again another 3-wire motor, and we're just going to plug that into port B here on our brain. Now that we have our bump switch plugged in, we need to set that up in our coding environment. So we want to add a device. Again, it's a 3-wire device, and we scroll up and we find the bumper. It's plugged into port B. You can change the name if you want. I'm just going to keep it as bumper B and hit done. We'll minimize that down, and then next on our brain screen, we want to be able to see the values for not only our potentiometer, but also our bump switch. So I'm going to do that before my if statement. So I'm going to come up here after my brain screen for my potentiometer, and then I'm going to tell it first, brain screen dot next row. I want to go down the next row. That way it's easy to tell them apart. And again, you could come over here to looks and drag and drop those over if you want as well. And then I'm going to hit enter, and then on that next row I need to tell it what to show up, what I want to appear. So I'm going to do brain screen and then dot, and now I'm looking at my bumper, so I want to again have it show up. So I'm going to type in print, and then I have to tell it what it needs to print. So inside this parentheses I need to tell it what to show up. So I'm going to say bumper B dot, and then the command's going to be pressing, so we want to know whether it's pressing or not. Then we have to make sure to close our parentheses. A lot of times, since it's got those parentheses there, you may not remember, but you have to close those parentheses at the end. So that's going to add that bumper, whether it's pressed or not, to our brain screen. Now I'm going to keep the rest of this code here. It's not going to affect it, and I'm going to hit download and add it into our code. So now we have our brain screen running. We have that code added. We can see it's got a value of 0. Then when I press that button, it goes to 1. I let go, it's 0. Press it again, 1, go back, it's 0. So hopefully this helps. So now we want to get rid of this potentiometer code, but we don't want to lose it forever. So I'm going to enter it, put a space up below it, and then I'm going to do 1, 2, 3 apostrophes before, and then I'm going to indent the same amount and do 3 apostrophes afterwards as well. And that gets rid of that code statement temporarily. Essentially what it does is make it a note in your code, so now it's read by you on the screen, but it's not read by the brain. And instead now we want the bump switch to control our brain. So we're going to type in a very similar statement. So we're going to do if again, but this time instead of potentiometer, we're going to do bumper, and our command for that was pressing, so we want pressing. And then afterwards, we want to say what value for that. So equal 1, and then we'll do a colon. Then we hit enter, and now we got to tell it what to do. And this is going to be the same command, so you could actually copy paste this command from up here. And I'm actually will do that just to make it go a little quicker. We're going to go Control C, and we're going to have that same exact command, and that's part of the reason it's nice to comment things out, because then we can easily go back and steal information that we have there. Once we have that, we want to download it and then test and see if that code works for us on our brain. So now we got the code downloaded to our brain. We hit run. Motor's not running back there. Hit the button, motor runs. Let go of the button, motor stops. Press it, motor runs. So now we have it. So when we press the bump switch, the motor runs, but when we let go, it doesn't run anymore. A lot of times that's not going to be the most useful application. Sometimes, a lot of times we want to press the button, it runs until we tell it to stop by pressing the button again. So to do that, we're going to start by adding a variable. We're going to do that above this while true statement. So we'll do that at the very beginning of our code. We're going to name this variable motor on, and we'll just type in motor underscore on, and then set it equal to, and again this is just one equal sign, not two equal signs, equal to negative motor on. And that's going to be how we have it set at the beginning. And then as we use it, we're going to have to toggle that value on and off as we press the bump switch. So to toggle this value on and off, we're going to come down to statements below, and I'm going to go to under if bumper B pressing equal 1, and I'm going to add in my code motor on equals negative motor on. So that's going to make that negative value a positive value, or vice versa, depending on whether it's positive or negative at that point in time. Then I'm going to hit enter below, and then I'm going to go back to the same indentation on that initial if statement, and I'm going to make a new if statement above my motor spinning. And I'm going to change that to if motor on equals 1, equal 1, then motor 5 will spin forward, else it's going to stop and spin backwards. Since it takes a little longer to press the button, I'm going to change my wait time from 0.05 and I'm going to make it like a quarter of a second, 0.25 seconds. Gives me time to press that button and release that button. And then while I'm here, I'm also going to make this value display on my screen, this variable value I just made up. I want that value to appear on my screen as well. So I'm going to go up to my screen statements. I'm going to go to the last one I have and do a new print screen line. So next row. And then I have to give it a new print command, print screen print. And then I have to tell it what to print. So now inside of parentheses, I want to do open quotes so I can tell it on the screen. It's going to say that my variable value mode on. And then I'm going to close my quotation marks, do a comma, and then what do I want it to show? I'm just going to type my variable motor on. After I've done all this, I should be able to hit download. If I did it correctly, I'll have no errors. I assumed I had an error, and I forgot my colon after my if statement I added. So we add that colon, and now we can download it, and it should function when we run this code. So when we add this motor on command, what we wanted to put was motor on equals -1. That would give us a negative value for that. So now when I download it, it should function appropriately. So now we'll download it and So we got that code downloaded to our brain. We hit run. Our motor's not going to run until we press our button. We press the button, we see our motor running, and then we press it again to stop. Press it on, and then press it off. Our last sensor we're going to use today is a limit switch. It's very similar to a bump switch. It says limit switch there on the back, so we know that's what it is. But this time it clicks over here on the side. It's again what we call a momentary switch. We'll plug that into port C, so we'll turn that over, go to port C, and plug that in on port C. And next we'll go and configure that on our... So now that we have our limit switch plugged into port C, we want to add it as a device. Add a device, go to 3-wire, and it's a limit switch, and which is on the top, and we plugged it into port C. Again, you can change the name if you want, but you don't have to, and we're going to keep it just as limit C. This time, next we're going to set it up on our, now that we have it set up, we're going to modify the code that instead of the bump switch, we use the limit switch to control our motor. So to do that, you could read the comment out and rewrite this code, or we can go through and change what it says bumper B to be our limit switch C. So limit switch C, and again, it's going to be the same command. It functions very similar to our bump switch. So limit C is going to be pressing instead of bump switch. And I'll do the same thing up here on our brain screen. I'm going to change that from bumper B to our limit switch C. And then we should be able to download that to our brain and then test that code. We got the limit switch coded now instead of the bump switch. So now when we hit the limit switch, the motor spins. Hit it a second time, the motor stops. Hit it again, the motor spins. Hit it again, it stops. So the last thing we're going to do is now use the potentiometer to control our motor speed while also still using that limit switch to turn our motor on and off. So the potentiometer is what we call an analog sensor. It gives us analog values, which means it gives us more than just an on-off values like these bump switch and limit switch do. So we're going to use those different values that we can get from our potentiometer to control our motor speed. So essentially 100% it's going to be full speed, 0% it's not going to be moving, 50% it's going to be moving at 50% of its max speed. So to do that, we're going to start by going in our code. We want to still be in our within our while statement. So I'm just going to put it right below this if statement so we know it appears right before we see in our code. So I'm going to type in my variable. I'm just going to name it motor speed. And then I have to tell it what it's going to be equal to. So I'm going to do just one equal sign, not two. And I want it equal to, and then to make it a number, I'm going to type in int to make it an integral. And then we have to tell it our potentiometer, and it's potentiometer A. And we want to be looking at the angle, and we want to use the percent, if I can spell percent, in all caps. And then what do we want to do with that? First, I want to take that percent and move it to a decimal value. So I'm going to divide it by 100. And then our motor has a max speed of 127, so I'm going to make it times 127. We always want it to spin in the positive direction in this case, so it's just going to be times with that 127. So that sets my variable value. Then I have to tell it in the code to make the motor spin at that speed. So I'm going to go right before my motor spins, so I'm going to go to where it says motor spin, and now I'm going to do motor 5, and I'm going to get out of all caps, motor 5. And I'm going to set velocity, and then I have to give it the unit, which is my value, which is going to be motor speed, and then I have to tell it what unit, and it's just going to be percentage. Close my parentheses. Once I do that, I need to download this code to my brain, and I misspelled potentiometer, so let's make sure we spell that correctly so it downloads to our device. So I'm going to spell it correctly this time and hit download. And I put a dot where I should have had an underscore, so that's what was wrong. So I'll re-download this, and then we should be able to, yep, it downloads, and we should be able to test that on our brain. So now we'll go over it. So we hit run. Our motor shouldn't spin until we hit our limit switch, because that's what we have it coded for. Right now it's going full speed because I'm at 100%. I move this down, and it slows down until I get to all the way down, and it stops. I go halfway, it goes about 50. I go all the way up, it goes full speed, and then I can hit my limit switch to stop it. So the code's doing what we want it to do. We can hit the limit switch again, and turn it back on, and then change the speed, and then stop it again with our limit switch. So today we used 3 different sensors, the potentiometer, the bump switch, and limit switch, and use those values to control a motor and how it functions. Hopefully this helps. Again, go back and use it as you need. Thank you.